We've got a question here which asks us to look at a body that's moving in a straight line. Now what that can mean is this body's moving in a straight line like that, and it might slow down and come back along the straight line and do anything like that. But it's in a straight line, which means its distance from a given point can be worked out from a formula, and it can be, or worked out from an equation, and it can be quite simple to do. To do this though, we should keep in mind that there are relationships between where a body is, so its position, what its velocity is, and its acceleration. So if I know a position, if x is the position, then I can say that the velocity is the change in position over time. If v is velocity, then the acceleration is the change in velocity over time. And because of that, it follows that my relationship between my position and my velocity, I can say my position is therefore the integral of my velocity with respect to time. And we're going to use that equation for this question. The first thing it asks is, given the velocity, which I know here, what is my position? So I'm going to use that first of all. So part A, I'm going to say, well, I know my position is the integral of my velocity with respect to time. Now, given that velocity is 2t minus 4 dt, so that equals 2t squared over 2 minus 4t plus c. Remember, we need our constant. Then its position will be this in terms of time. But we're told that the body starts from 0. So it starts at the origin. So I can say when t equals 0, x equals 0. Therefore, 0 equals 2 times 0 squared over 2 minus 4 times 0 plus c. So c must equal 0. So therefore, my displacement at any point in time will be t squared minus 4t. And I get that from this line here. 2t squared over 2. Obviously, I can cancel out the 2's. So it's t squared minus 4t. That's my answer to part A. So I'll lock that in, and I'll start now with part B. B says, what's its position after 3 seconds? So what it's asking for is, when t equals 3, what does x equal? So I can do a direct substitution. X equals 3 squared minus 4 times 3 equals negative 3. So its position after 3 seconds is at negative 3. And so I'll box that up, and there's my answer to part 2. So now that's locked in, I'll do part 3. And it asks for the average velocity. Now remember, the formula for the average is 1 over b minus a by the integral between b and a of, because it's the average velocity, it's going to be velocity dt, which equals 1, now it's in the first 3 seconds, so it's going to be 1 over 3 minus 0 times from 0 to 3 of 2t minus 4 dt. Now we had this worked out before, but unfortunately I've gotten rid of it, so I'm going to have to do it again. A third of, it'll be t squared minus 4t between 3 and 0. I'll keep going over here. So that's 1/3 of 3 squared minus 4 times 3 minus 0. And remember, I have to take a third of all of that, which equals a third of negative 3 equals negative 1 units. Now velocity will be units per second if you want to, or units, it doesn't matter. Here though we're given centimetres per second. So let's remember this call and response idea and make the examiner love us. So rather than writing units, we're going to write the average velocity equals negative 1 centimetres per second. And there's our answer for part C. The next part asks for the distance travelled in the first 3 seconds. And this one's a bit tricky, so we need to be very careful. Now, it's possible, as I said, this object is travelling and it may have turned back around. So we need to find out, is there a point in time in the first 3 seconds where the velocity equals 0? So let's find out. If the velocity equals 0, then 2t minus 4 equals 0, because this is my velocity. And that actually happens when the time is 2. So we need to find out where the object is when it turns around. So we'll go over here and we'll say when t equals 2, x equals, using this formula here, or this equation, 2 squared minus 4 times 2 equals negative 4. So that means my object has travelled from the start. So if I want to draw my axes, it's travelled from the start to negative 4. And it's at negative 4 after 2 seconds. Then it turns around and it comes back after 3 seconds, it's at negative 3. Which means it's travelled a total distance of 4 and then 1 more unit to get back. So therefore, the total distance travelled will be the 4 plus the 1 will be 5 centimetres. So we need to be careful when we get a question like that, because the object may have turned around. And in this case it has, so we need to add the distance going left to the distance going right. And finally we need to find the average speed in the first 3 seconds. So the average speed will equal the total distance over the time, which will equal 5 over 3 centimetres per second. And that will be my average speed. Now I could have done the same thing for the average velocity when I had a distance of negative 3 centimetres after 3 seconds. I could have divided that, but I wanted to show you that that can be done using integrals as well. We would have got the same answer. So there's how you do quite a complex question that's asking about a moving body relating position and velocity, and occasionally you'll also get it to relate to acceleration.